part, this is the first time the question asks you to find the partial fractions without giving you the form. Tricky like that. So they want you to write this as a partial fraction. So first things first, we factorize the denominator into this. So as a partial fraction, it's proper, that's nice, a over x plus b over 1 minus x. Multiplying through by the denominator, I get 1 equals a times 1 minus x plus b times x. If I make x equal to 0, then that would mean a equals 1. And if I make x equal to 1, that means b will equal 1. So I have it as a partial fraction now. 1 over x times, well, I'll put it back as it was, 1 over x minus x squared equals 1 over x plus 1 over 1 minus x.
What's the difference between this one and the other one?
In the other questions, the question would begin by saying this equals a over that plus b over that. So in this case, I did not give you the form. That's A part 1 taken care of. A part 2. Solve this equation. So this is dp over p minus p squared equals dt. This is integrate 1 over p minus p squared dp equals integrate dt. The integration on the right is easy. What should I do with the integration on the left? Use the partial fraction result. This can be written as integration of 1 over p plus 1 over 1 minus p dp equals integration of dt. Both of these are in the log formula book, so by looking at the log formula book we get log p minus log 1 minus p equals t plus c. When we minus, we divide. Log p over 1 minus p equals t plus c. To cancel the log, I'll put an e on both sides. P over 1 minus p equals e power t plus c, which I'll write as e power c, e power t. C is a constant, and e power c is also a constant, so I'll just call it a constant a, et, p over 1 minus p. I'll multiply. P equals 1 minus p times aet. So p equals aet minus ap et. Taking the p's to the left, p plus APET equals AET. Now on the left I can factor out the p. P 1 plus AET equals AET. In fact, I should maybe find the A, but I'll just do that at the end. I can divide by that now and get the P is A over ET over 1 plus AET. Although I have to find the A. I know that when T is 0, P is a half. So if I substitute that in, P is a half when the T is 0. So that would be A over 1 plus A. So I hope, I'm not going to bother solving it, but you can actually see what the answer is. A is 1. The only possible answer that can make a fraction of a half. So A is 1, which is nice. The answer is ET over 1 plus ET. Yeah.
blow up a bit.
There you go. Yes?
Reason why is the log minus log 1 minus b? Like instead of plus log 1 minus b.
Look at the formula book and look for the integration of 1 over 1 minus x. It's the same as 1 over minus x plus 1. The a coefficient, the x, goes into the denominator of the answer. Just look at the formula book. Open up the formula book.
Could I change the et equals c into e equals t?
Not necessary. Didn't need to do it. Just c is a constant, e is a constant, e power c is also a constant. It's just convenience. Sunita. Oh yeah. You can substitute at any point, and normally I substitute at the start. I just didn't this time, just because I forgot to. But you can substitute at any point. Any other questions with this? Okay, there's still a B part to do. So the B part here, use the Newton-Raphson's method, find the root, and you're told where to start, at minus 1.5. So fx equals 1/6 x cubed plus 1/2 x squared plus x plus 1. The derivative here would be 1/2 x squared plus x plus 1. Newton's-Raphson's formula is this. And we put the fx on the top. 1/6 x cubed plus 1/2 x squared plus x plus 1. And here 1/2 x squared plus x plus 1. And we're told to start at minus 1.5. So we just put minus 1.5 into the formula and we calculate the answer to be
Isn't x0 minus 1?
I just mean to start at minus 1.5. I called it x0. You usually call it x1. Answer to that one divided by 6 plus this one, that one divided by 2 plus that plus 1 over that squared over 2 plus that plus 1. So when you put this in on your calculator, you'll get minus 8 over 5 is the next one. And if you put minus 8 over 5 in on the calculator, minus 407 over 255. No, because in the question I said the root is between minus 1 and minus 2. It shouldn't fall outside of this.
Yeah, the final one that I found is minus 1.3.
Yeah. This here is... I got here minus 1.596.
Are you sure
Are you sure
it's
you typed? Let me double check. That's right. Yeah, it looks okay. I think I have it okay here. Now there is one way to check. Our calculator can tell us the roots. So if one of the roots is near this, we can know mode 54. It is? Okay. Yes. In fact, this cubic has only one root. Okay, and that's B5 done. So the Newton-Raphson question is a nice question in the exam. It's just a bit of calculator work. They usually have it, yeah, usually.